right, we're going to continue with rates of change. So other rate problems can be treated in the same way as those involving time. However, we must always pay careful attention to the units of quantities involved. For example, the cost of manufacturing X items has a cost function, C of X, where the dollars associated with it. So the derivative function would be the instantaneous rate of change in cost with respect to the number of items made. So the derivative unit of time is going to be instead unit dollars per item. Another example, a profit function, P of X, is making and selling X items given by this equation where you are subtracting the revenue function from the cost function to give you your profit. So the derivative function would represent the rate of change in profit with respect to the number of items sold. So here's an example. The cost of producing X items in a factory each day is given by this cost function in dollars. And the interval is from 0 to 600. So part A says find the C of 0 when X is 0 and what does it represent. So we're going to substitute 0 in for X. And what we're left with is just the 2200. So what does that mean in regards to our application problem? This value represents the fixed cost for the company to operate even without manufacturing anything. So if the company does not produce anything, they still are having a cost of $2,200 a day. Part B says find the derivative function. So let's find the derivative. So we're going to bring down that power of 3, then subtract our power, bring down our power of 2, subtract our power, and then drop the x. So when we simplify that function, actually they're leaving out here a 1 and a 3. When we multiply that coefficient, we get negative 0.000039x squared plus 0.004x plus 15. So there's our derivative function. Part C says find the derivative function with a value of 150 and interpret what it represents. So we are going to substitute 150 into our derivative function in part B. And then we would use our calculator to simplify that. And we get 14.72. What that represents, it is per item, the cost per item. So this is the rate at which the costs are increasing, because that is a positive 14.72, with respect to the production level X when 150 items are made per day. So what that means is it's giving us the estimate of the cost of making the 151st item. All right. Moving on to part D. Part D says find the cost of 151 items minus the cost of 150 items. So we're going to use the original function. So we would substitute 151 into the original function and then subtract it from the cost of 150 items. So let's start off with the first evaluation. And we'll be using our calculator. So there's evaluating for 151, and then we're going to subtract $7 and 150, and this was all just going to go in our calculator. And the two values you get is the first is 44,654, so that's the cost of 151 minus the cost of 4451.3. That's your cost of 150. And when you subtract them, it's about $14.71. So what this is the actual cost of making the 151st item each day. So notice those two answers are very similar. Now off to the right, I did put the graph for you of this function. So here is that curve in the red. And then we have our tangent line. And that would be the answer at 150. And then notice this is the chord, the distance between those 2 points for answer D.